Hello, this is Professor C.P. Prakasham, former professor from International Institute for Population Sciences, Mumbai. I will be discussing cluster analysis by using SPSS. Cluster analysis. Cluster analysis can be understood in a very simple way. Cluster analysis is an exploratory data analysis, and it is tool for organizing observed data into a meaningful cluster based on combination of variables. Cluster analysis refers to a class of data reduction method used for sorting cases or observations for a given set of data into homogeneous groups that differs from each other. Here the groups will be, within the group it will be homogeneous, and between the groups it will be different. And then this reduction method, the variables reduction we will use by using the factor analysis, and the observations or cases reduction we are using the cluster analysis. Cluster analysis is a multivariate data analysis technique to group the objective cases based on a set of user selected characteristics or attributes. Clustering procedure is as follows. Basically, it can be divided into two parts: hierarchical procedure and non-hierarchical procedure. In the hierarchical procedure, agglomerative as well as divisive procedures are there, and in the non-hierarchical procedure there will be k-mean method is there. There are other methods also existing. That is a two-step cluster, centroid-based clustering, distribution-based clustering, density-based clustering, and other methods also existing. But whereas SPSS will offer three methods of cluster analysis, that is hierarchical procedure, k-mean method, and two-step cluster methods. We will be learning further what are the hierarchical procedures and what are the steps involved. Clustering procedures. Hierarchical cluster procedure. Agglomerative method. It begins with as many groups as there are observations, and then systematically merges observations to reduce the number of groups by 1, 2, 3 until all single group contains all observations is formed. Another method is divisive. It starts from one cluster and go to the n number of clusters at the end of the cluster and forms the clusters. Non-hierarchical procedure, that is the k-mean cluster method. It begins with a given number of cluster groups and an arbitrary assignment of the observations to the group, and then reassign the observations one by one, so that ultimately each observation belongs to the nearest group. In the k-mean clusters, the number of groups or number of clusters is decided by the researcher. How to decide, and that will be discussed in the next coming slides. Two steps cluster, but this is very rarely used. Two-step clustering procedure, initially it identifies groupings by using quick clusters algorithm, and then by running hierarchical methods. By using quick clustering algorithm, it handles large data sets. Two-step clustering can be handled large data and also an ordinal data in the same model and select the number of clusters. Therefore, it is used for the large data set as well as the ordinal as well as the interval scale data. Let us go for the hierarchical clusters. Hierarchical cluster analysis follows three basic steps. One is to calculate the distance for measuring the similarities. Number two, link the clustering, and number three, choose a solution by selecting the right number of clusters. This is the hierarchical clustering procedure. And then how it will go theoretically, we will be getting some idea here. Measuring the distance, first step. There is a method called Euclidean distance between the 2 points is given by Dij equals to root of summation of observations from k equals to 1 to n xki minus xkg whole square, where Dij is the distance between cases, that is observations I and j, and xkj is the value of the variables x for the case j. Another method is modified by the Euclidean distance method is squared Euclidean distance is calculated by using Dij equals to sum of xik minus xkj whole square. Third one also is used according to the data set. Absolute Euclidean distance, that is the Dij equals to sum of absolute values of xik minus xki. Here one should know that the Euclidean distance, the smaller the distance value, the more similar cases, and above 3 measures, that is the best decision. The smaller the distance value, the more similar the cases. That will be grouped into one cluster. Above 3 measures of distance depends upon the units x1, x2, x3 and are measured, and the variables takes a large value. To overcome this standardized values will be used. And another procedure is that by using the entropy method, that can be linkages method. There are few methods are available. Single linkage, which will have the minimum distance of the observations, complete linkages, maximum distance, average linkage, and Watt's method of linking of that. The aim of Watt's method is to join cases into clusters such a way that variables within the cluster is minimized. Another method is the centroid method. The distance between two clusters is identified as the difference between the cluster averages. To choose a solution, initially perform a hierarchical method to identify the number of clusters from the data set. Next is that after selecting the number of clusters from the hierarchical cluster, choose k-mean clustering method for the number of clusters selected from the hierarchical method to derive the results. That procedure will be adopting here. Then what are the limitations of the cluster analysis? The different methods of clustering usually gives different results. The analysis is not stable when cases are deleted as outliers. That means as you go on deleting the cases, the sample size will reduce, and then sometimes only one case will form one cluster and another case will form another cluster. There will not be any cluster members in that. Then let us go for the example by using the SPSS. Here is the example for that. Health Program Manager evaluates the antenatal care performance leading to safe delivery in the districts on the basis of antenatal care services provided to the pregnant mothers in a selected state. It has been hypothesized that the availability of antenatal care services, accessibility of the ANC services, place of delivery leads to safe delivery. By using cluster analysis, the districts are grouped into best, medium and least or poor districts regarding safe delivery by considering the antenatal care services. You can see in the table number 1, right side, is the data of the districts followed by the number of the variables are here. These variables are V1 refers to government facilities for the antenatal care. Number 2, V2, 3 or more antenatal checkup is taken by the pregnant mother. Number 3, full antenatal care services utilized by the pregnant mother. V4 is the percentage of women who had an institutional delivery, and V5 the women who had safe delivery. This is the data, the right side the data is given. Let us see that by using the S-spaces, how to calculate the clusters and how to form the clusters and make the decision about the cluster. So this is the data for the cluster analysis. Here you can find the district names and then variables V1, V2, V3, V4, V5 in S-spaces editor sheet, data view. Then come back to the variable view, you find V1, V2, V3, V4 and the labels for each V1, V2, V3, V3, V4, V5. Now we are interested to do the cluster analysis. Go to the analyze and then click analyze, classify. In the classify you find hierarchical. Click that hierarchical cluster and then bring the variables to the right side. Each variable, whatever variables it is decided. We want to find out all the variables and then for each variable we want to give the label which they belongs to. That is the district. Then come to the statistics. Statistics is given, agglomeration schedule is a default, continue, and then plots. We want to have the plots as a dendrogram and click that, and then method wise is important, cluster method what we have discussed earlier. Then we are interested about the Watts method, which is a more powerful and effective. Then measuring the interval distance by using the squared Euclidean distance method. Then each variables will be transferred into a standardized variable by clicking into the Z-score. Once this is done, say continue. Once it is continued, then we can go to the OK. Once you click OK, you will get the output. This output consists of the cases processing summary. That is, there are 22 cases are there and there is no missing value, and total has been considered all the variables. Then coming down to that, how the clusters have been linked by using the Watts method. This consists of the stages. First stage, in the cluster, the combination of 6 and 9 variables, and then the coefficient which has been measured by using the Euclidean method is given here. This is most important in that. Then come back to that, cases which have been related is given, and then the dendrogram which is important. If you look at this here, 6, 9 and 10 initial has been grouped into one. Similarly 17, 19 and 16, like that it has been grouped. Therefore this is the first group, first cluster, this is the second cluster, this is the third cluster, this is the fourth cluster, and this is the fifth cluster. All the variables have been selected in the hierarchical analysis. Therefore, how to make it is a very important clusters. All the variables are included and then made a 5 clusters, and then all the way we have to identify the each cluster and then minimize that cluster number. That will be done by using the k-mean square. Here, how to do that? Here, what we have to do that, first of all, we have to identify the coefficients where there is a large difference is existing. For that purpose, we will consider this and prepare a diagram, that is the curve, where there is a jump is there that can be identified by using the graphical method. From the SPSS output, we got the agglomeration schedule, and where the coefficients are given, the values of the coefficients are given. Here we have to find out where is the big jump of the coefficient to identify the effective clusters. Therefore, this data, agglomeration schedule data, will be transferred into the SPSS. From the SPSS, we go to the Excel sheet. From the Excel sheet, we got this to draw the graph. This is the agglomeration schedule data, and then this is the coefficients, and that has been plotted. Coefficients by the stage is given. Once you observed here, there is a jump from the 19th observation, that is 46 to 63 to 105. There is a big jump is there here, and then if you consider the total number of cases is 22, and from the stage where we observed is 19, from the number of clusters to be formed will be decided by number of clusters equals to number of cases minus number of stages. There is a number of clusters equals to the number of cases 22 minus 19 equals to 3. The effective clusters we can form 3. This, how to form this effective clusters by 3 is by, we can use the k-mean clusters by using the cluster analysis. In the earlier, we have selected the how many clusters we have to select. For that purpose, we will use the k-mean cluster method. Analyze, classify, and go to the k-mean clusters. Once you got the k-mean clusters, click here and bring back all the variables into the right side as it has been done for the hierarchical clustering method. Then label these districts as a district label. Then number of clusters you can choose. Since we have decided 3, then click number of clusters. Then iteration will be selected automatically, and then save this. This will give us the how many cases belongs to that particular cluster, and cluster numbering we require. Then click here. If you want options, go to the options, and then initial cluster centers, then analysis of variancy, and cluster each information of the case. That will be, it's not that much necessary for us. Therefore, say continue. Once you say continue and then save OK, you will get the output here. This output here will give the initial cluster center. After iteration, then it will give the final cluster center. This is important for us. And then analysis of variancy of each cluster center. What is the mean square, whether it is significant. Though it says that F-test should be used only for descriptive purpose only, and not for choosing the hypothesis testing. But this will give an idea that there is a significant variations are there within the between the clusters, and homogeneity is existing within the clusters. And then give the cluster numbering. For the first cluster, there is one case, that is one district has been selected. For the second cluster, there are 10 cases or 10 districts have been selected. Third, it will be 11. Out of total observation 22, total districts out of 22, then this is the clusters have been given marked here. Then this data of the cluster centers have been transferred into the Excel sheet and identified according to the cluster numbers. When you see the cluster numbers, you see here in the SPSS, the last column, when you say save, it has been stored as that. That is, first case is number 1 cluster, second case third cluster, like that. 1, 2, 3, 4 will give us the, it is not a chronological ranking, it is a cluster A, cluster B, cluster C. Like that you can also label it. Then after these clusters are there, then we can transfer it into the Excel sheet and see by using this. This is the Excel sheet. This Excel sheet will give us the cluster number, the districts, variables V1, V2, V3. These numbers are the final cluster centers of each variable, and this is the district, and this belongs to the 2 category, this belongs to 3 category. Now comes the judgment. Once the V5 is the safe delivery system. The safe delivery is the highest having the center, and numbers are given here. And here the cluster number 2 is having 72.54, and here it is 46.3, because there is only one case is there, one district is there in this. Then from this we can decide that this is the best. These districts can be classified as the best, and these districts are classified as the medium, and this is the poor districts in performing the safe delivery system by all the variables which have been selected. Infrastructure variables and as well as the utilization variables leads to the safe delivery, and the safe delivery is poor here, and then safe delivery is the best here among these districts. The health manager can decide, and then plan of action can be decided upon.